and thank you for joining me today. My name is David Myriel, and I work at Qdrant, which is a vector database and a search engine company. We have an existing integration with Redpanda, and that's what I'm going to talk about today. If you're using products like Redpanda Connect or Sovereign AI, you would stream your data to our database for storage and retrieval. The general theme of today's talk is data privacy and sovereignty. Specifically, I will talk about vector data and how it can be securely streamed to a database like Qdrant. Then I will take a look at the ideal privacy stack, and I will show you how to build data structures that give rise to sovereign architectures for all sorts of RAG and AI application. So first, a little bit about myself. At Qdrant, I support a global community of over 45,000 developers working on machine learning and AI projects. My passion lies in making complex technologies accessible to developers. All right. To understand data storage for RAG, we first need to understand vectors. We like to think of vectors as the language of AI. These vectors are how AI systems understand sentences and process data such as movie reviews from, let's say, 2001: A Space Odyssey, a very popular movie very close to our heart. If you want a sci-fi movie recommendation, you're most likely working with Qdrant on the back end if you're using a website recommendation platform for movies. Our company operates in the same space as popular products like MongoDB and Elasticsearch. Like MongoDB, we excel at efficient storage, and like Elasticsearch, we offer super fast and flexible retrieval features. But there is one major difference with Qdrant. Qdrant is purpose-built for vectors only. While MongoDB and Elasticsearch treat vectors as add-ons to their core, Qdrant treats vectors as first-class citizens. The vector index functionality has been built into the lowest levels of our product, which is visible in many ways, and particularly when making the indexing and search more effective, but also when protecting access to data in other ways. If your application revolves around vectors, Qdrant can handle all of them. We're compatible with most modern embedding technologies, which means the database can ingest images, sound, video, text, tables, PDF, or really anything you can think of. If a file can be embedded, then it can be stored and you can search through all of this data. Also, Qdrant makes real-time data ingestion easy with Redpanda Connect. You can have any kind of vectors flow through Redpanda and get deposited into our database. Whether you're working with dense vectors, sparse vectors, named vectors, or multivectors, or even complex metadata payloads, this setup is really fast and scalable. Our integration details are featured on Redpanda's website and also our documentation website for Qdrant. And you can see here in the screenshot some of the basic output configuration. And this is all that has to be set up for a proper ingestion pipeline. And in this first demo, I'm going to show you how to do this in real life.
Let's start by running the Qdrant dashboard. First, we're going to create a collection. We'll call it RPK. This is a collection that will store our data. The name of the collection is RPK, as you can see here. We're using UID as the identifier, and as for vector mapping, we're defining the embedding property. This embedding property will store the vector data. The payload will represent additional properties, which we will pass as input. Let's proceed to connect and set this up. The system will automatically handle the installation of the required tools and models for you. I've already done this, so the process is quick and interactive. Let's clear the screen, and now we'll test this setup. For demonstration, let's use a simple input text. Let's say hello from vector space. When you run this, it inserts the data. If we now go to the collection, you'll see we've added a point and the text hello from vector space is successfully stored. Qdrant also supports advanced features like sparse vectors and named vectors. Named vectors allow you to associate multiple vectors with a single data point. Let's explore this. If we want to update the collection, we can create additional named vectors like v1, v2, and v3. For instance, v1 can store a dense embedding with 768 dimensions and the cosine metric, and v2 can store 384 dimensions and the dot product metric. Finally, v3 can define your sparse vectors. You can mix these as needed. Now, how do we insert vectors? Suppose we're using a 768-dimensional embedding generated by a text embedding model. We'll name this vector v1. The process is straightforward. You just specify the vector name during insertion. If you have additional embeddings, let's say sparse vectors or vectors from another model, you can insert them as v2 or v3. This flexibility allows you to store multiple embeddings per data point. Once the vectors are saved, we can go back and test the setup. Let's add some new text, such as, hey, when we insert this data, the corresponding vector will be added to the collection. Refreshing the dashboard will show the new point with the v1 vector and the associated text.
When it comes to agentic systems and RAG systems as well, they act autonomously and they make decisions based on massive data inputs. And that's why they face difficult and unique challenges. These systems must process enormous amounts of sensitive data, and with the rise of Gen AI, these privacy challenges are becoming more critical. So Qdrant is open source, and this is vital when keeping data in-house. This lets organizations see completely how their data is handled. So the first thing that I want to talk about is data isolation. And with Qdrant, you get secure, efficient, and scalable data management that's purpose-built for modern applications requiring stringent data isolation. We have a multi-layered approach to data isolation with a double layer of security. We call it multi-tenancy and sharding. Multi-tenancy ensures that data from different tenants is logically separated, which is crucial for multi-client applications. And as you can see in the diagram here, the entire application is housed on one collection only, but the collection is chopped up in different tenants. Those could be users or departments, and each of the vectors uploaded to the database is assigned its own tenant, or they can be shared across tenants, of course. Of course, sharding also, just to go back a sec, physically distributes data across multiple nodes or servers, and it creates an additional layer of isolation, which improves system performance. So this is a kind of a two-pronged approach to data isolation. And with these two, you can make sure that workloads from one tenant don't impact others, which is essential for high-trust applications in industries like healthcare and finance. So let me get into a little bit of a demo in a second after I show this code. And here you can see how data is divided into two different tenants. You can assign a group ID to each vector, and then you would filter your searches by this ID. So for example, let's say we're working with one user number one and user number two. You would search your points, your data in the database by one user, and you would only have access to that data. So second user's data would not be available. So let me go ahead and demonstrate how this works in Qdrant. So inside of our dashboard, which you can host locally, we have some tutorials that demonstrate multi-tenancy. And a multi-tenant setups for, let's say, kind of a library or a library for a large enterprise can be set up. So a collection where you would store your information, and then you would create a tenant index for a group ID. You would run this. So you would group all of your tenant data in one spot. You would load the vectors for individual tenants, such as the communications department, the security department, or engineering teams, and you would add it to the collection. And now all of this stuff is in the same collection, but it can be accessed only if you run a specific filtered query by the tenant being user one. So let's go up and see which one of the users it is. It's the communications department. You can run your query just for the communications department, and you would receive your response with the respective payload containing any kind of a message. So when it comes to sharding, the shard is not defined in the payload, but it is still part of the data model as a parameter of the point. Each set of vectors can have their own shards, which means that they can essentially be distributed in different regions and nodes of the same cluster. Let's take a look at how an index data structure is built for custom retrieval inside of a shard. As we index the payloads and mark them as tenants, we can essentially denote which are the departments, which are the departments and how they're separated inside of the collection, and the internal system will arrange it for easier access inside of the shard. And here we have a code example of how to set up shards. So we have a custom sharding method that can be turned on in our configuration file that I'm going to show in a second. And once we attach a point or we upload a point to the database, we simply have to denote which shard it is. So in this case, we used a country for an example because usually shards are hosted in different nodes, different locations, which means that you would have a really great distributed system across the globe, all shared within the single collection. Okay, so now I'm going to talk about data security, which is the next level up. And I'm going to talk about encryption and access control. So database security can be set with end-to-end encryption across access, transfer, and storage. For data access, security APIs and role-based permissions ensure that only authorized entities can interact with the database. And we do this through API key-based tokens, and we also do it with RBAC with JWT token-powered RBAC features. As well as when it comes to the transfer of data, during data transfer, you can use transport layer security, TLS, to encrypt all communications. And this prevents data interception and ensures secure connections. So I'm going to show you how this is done from the configuration file of our database. So let's go ahead and, for example, we have something here. We have a cluster here in a container. I'm going to go and look for the config YAML file, which belongs to each individual instance. I'm going to open up the file editor, and I'm going to look for the TLS config. So the TLS configuration section is right here around line 319. And here's where you can set your certificate and as well as your key. So this is all you have to do really to protect the data transfer in your instance. And you can also do this between individual instances as well. So we do offer P2P transfer security. And the third option is data sovereignty. So today, I also want to close out by discussing how all of this ties together. Because a lot of businesses need to keep data within certain regions, or they need to meet specific rules like GDPR. With Qdrant, you can deploy a single database wherever you need, on-premise or in a particular cloud region, so you can stay compliant and in control. When it comes to bring your own cloud solutions, many companies mix on-prem infrastructure for sensitive data with public cloud resources for scaling. Qdrant fits into this setup easily, and you can keep sensitive data secure while using the cloud for bigger processing tasks. If we look at the architecture of a hybrid cloud here, you can see that there is no API level connection between the public internet and your internal private cloud. Everything is contained inside of your own area. Your agent, your Kubernetes API, and the Qdrant operator are all inside of the hybrid or private cloud location. And the only thing we have on our end is the monitoring and the telemetry. So let's talk a little bit just quickly about monitoring. It's important to know how your system is doing, so we do consider this a part of security. And Qdrant does include tools for tracking performance, keeping logs, and setting up alerts so you can catch issues early. And you'll have the visibility that you need to keep things smoothly. So I'm going to close it out here with a kind of an overall architectural diagram of what a GenAI architecture would look like. So this is what we just discussed, a private cloud solution where a hosted database is located, and it can also be hybrid, of course. But the data pipeline that is managed by, that is organized and orchestrated by Red Panda Connect and Sovereign AI can be located inside of a cloud solution as well. So you would start with your source collection or your source database. You would use the private embeddings provider, and then you would stream your data from, you would ingest the data with the Red Panda Connect, and you would ingest it into the database for processing and retrieval. This would then be turned over to the LLM for generation and then for the end user. And that's pretty much it. I am going to leave my information here, and I'm going to be available for additional questions at the end of the presentation. I want to thank you for joining, and I'd like you to take a look at our information on Qdrant.tech and Qdrant Engine Twitter. And if you have any additional questions regarding the product or technical inquiries, you can reach out to me on LinkedIn or through email. Thank you.